Hey guys, welcome to the channel. Today we are going to do something different than what we normally do in our channel. Most of my videos are on web development and AI and all that, but today I want to present something different. I was fiddling with a lot of C and then I wanted to just create like a very small project, working project that I can share with you guys. So here it is. We are going to build a tiny shell. I actually named the project Tiny Shell as well, but it's going to be a very simple shell where you can go ahead and run commands like ls, change directory, print working directory, all that, and also be able to run programs which are installed in your system, right? Just like a normal shell. But it will be very tiny. It will not have all the features that full-fledged terminals or shells have, but yeah, I mean, it will be a good learning project. So let's get started. So here you can see editor. I'm not going to use any AI or anything in this, at least. So we are going to use C programming language. So I'm going to create a file here, tinyshell.c, right? And if you guys still don't know or don't know about what is a shell, you can just um, just go to your terminal and you basically know what your shell is. For example, you can see it's GJSHS is basically a shell right now, right? And a shell allows you to do things like, ls, like what's in the directory. Then you can also change it directly. If I say change directory dot dot, it will go to the parent directory, and you can see I have these folders here. And then if I go again, change directory tiny shell, it will basically let me um, go inside the directory, and I can do whatever I want here, like ls or ls-la to show you all the things, or I can just do pwd as well. So yeah, so we want to build this basically in C and then able to run like these commands inside that shell. So let's get started. What we need right now is to create a REPL. REPL is basically, this is a REPL. So for example, if I do ls and hit enter, it gives me the output, but then, you again have an input basically where you can put your another command. So ls-la, I come back to this. So this is kind of like a non-ending loop, or forever loop, or a, continuous loop, right? So let's create that. So we are in C. First, we're going to define our main function, and from main function we're going to return 0. So return 0 is basically, the program was successful. And then we are going to basically create a loop. So we are going to create a never ending loop, or a loop which we can only break from inside. So we're going to say while 1, which is basically, while everything is true, 1 is true or 1 is 1, we have to keep running this loop, right? And then for example, you can see this is like a prompt basically, and we're going to print that prompt here. So in C, so you can just do print f, and you have to include the stdio library above, but you can just do print f, and then I'm just going to say tsh, and that's basically it. Like this is like uh our, like, the smallest version of the initial version of our shell. Let's try to run it and see if this works. So I'm going to use GCC compiler. So GCC uh, tiny tiny shell.c, and output being tiny shell, right? So this will it will take our C file and then output a executable binary which we can execute in our terminal. So I hit, it says error because it's not 0, it should be O. O is like for output, and you hit enter and it compile, and you can see the binary here, and I can run it like this. So I'll just say dot slash tiny shell, hit enter, and you can see, it is a non-ending loop basically. So you can see it's happening. So that's great, right? It works. We don't want this program to work like this. So what I'm gonna do is flush the std out. So flush the std out, and that basically means, so this is basically, we are going to flush the std out. So it's like, sometimes when we printf and do things, sometimes things stays in buffer, so we are just going to flush the buffer, like, which is the output buffer, and then we are going to ask for input. So the way we are going to ask for an input is F F gets, that is for basically from where we are going to take the input, or to which we are going to put the input. We are going to put our input in a variable called input. And we also have to provide a size, like what can be the max size of that input. So we are going to define a variable called max input here, and from where we are going to read the input, which is std in, right? And if for whatever reason this is null, then we are going to basically show an error, p error, and we just say f gets failed, that it didn't work for whatever reason, and we're going to continue. So the reason we are going to continue is because we don't want to close the loop. We still want to, try next time getting the input. But now you see, like, we don't have these variables, so we have to define these variables. So what I'm going to do is define a macro. So has define a macro max input, which is basically what can be the max length of our input. So I'm gonna keep 1024. Uh, I think this is a good number, right? And then input is going to be basically where we're going to, um, you know, whatever the user enters, we're gonna save it inside the input, right? So for that, I'm gonna define a char here, character input with a length of max input. So this kind of like a string, right? An array of characters or string, whatever you want to call it, string. So and then it's of the max input, so it can have a max length of 1024, right? And what will happen now is if fget, so we will try to read the input whatever the user put in the stdin, like in this terminal terminals, and if it is not equal to if it is equal to null, then it's an error. If it is not equal, then we'll just keep going. And then what I'm going to do is I'm just going to print f whatever we just read, right? So I'm just going to say dollar $s here to print out the input, right? And let's see if that works. We're going to go here, tiny. No, I have to compile this first. So compile, hit it, and you can see like we have this input that we can write here. So if I say ls and I'm able to write like things and hit enter, you can see it output. So saving the user input inside the variable input is working. That is great. Um, right? So you can just say ls, whatever, and all that, right? Now let's implement a command which will break the loop, which will basically help us get out of this program. So right now I have to do control C to exit out of it, but I want like a exit command which will let me exit out of this shell, right? Let's do that. For that, um, I'm going to use something called string compare to compare the strings, right? So I'm going to say if string compare, and I'm going to compare, and we have to include string.h for it. It randomly did it for me. The string compare, we have to put the first string, which will be input, and the next string, which let's say our command exit, if equal to 0, that means it matched. We are going to print, let's say, have a nice day or night, you know, just trying to be, yeah, so just trying to give it a character. So, we're just going to say have a nice day or night, and we are going to break the loop. So this is going to break the loop basically. And so this will not run. It will basically exit out of that, right? Let's see if that works. So I compiled it and inside it, I do ls or whatever. If I do exit, it should exit out, right? But it doesn't, right? And I know the reason behind it. If I again, exit to exit, it still doesn't work. The reason is that when you type exit and hit enter, when you hit enter, it actually add a slash n delimiter um, into the string, right? So there is a special character slash n in there. So if I do slash n, then it will work. So I do exit, can't exit, so control C. Um, and I compile, and here ls this. If I exit, have a nice day or night, whatever goes out. But we don't want to do that slash n, because even when we have other commands, we always have to like take this in account for. So what we're going to do is we're going to remove it. So the way uh, easy way to remove this is whenever you hit enter, we are just gonna remove it, right? So what I'm gonna do is input. I'm gonna find its index. So I'm gonna do that using stir span. So stir CSPN stir span, and I'm gonna firstly provide the string, which is input, and then I'm gonna provide the char set that I want to remove, which is slash n, and then I'm gonna put there a null termination. um, I'm gonna null terminate the string. So if you don't know, this is a way to null terminate strings in C, which basically means that this is the end of the string and you don't have to go further than this. And let's see if this works now. So we have removed that slash n from here, and also like removed it from the string. So let's compile this, go into TinyShell, ls, cd. Now you see this, what's happening? It's not. So where here it was going to a new line because there was a new line here. We removed it, so it's showing up like that. So I'm actually going to add a slash n here. But yeah, so for example, let's try exit, and we are able to exit. Compile in again, go in here, ls. Now it will work because we just added a slash n here, right? So yeah. Now that's great. It works. If I hit exit, then have a nice day or night, whatever. That's good. Now let's try to execute commands, right? Like ls. Let's you know get to that logic. To get to that logic, what we have to do is basically, for example, if I go to my tiny shell, I can do something like this, ls-la, right? And that basically means, or like cd to dot, right? That means basically these are tokens in a string. So in input they are tokens, and we have to figure out what is a command and what is the arguments of it. So for that we have to save arguments somewhere, right? So for that I'm going to create a string of strings basically. So I mean array of strings. So and it will have a max argument because we don't want to overflow. We don't want to control like a lot of things. And this is very tiny shell. This is like the just for learning. So we're not going to allow it to be dynamic or anything like that. So we'll just put max args here, which is basically the maximum args you can provide, and we're going to define um, max args here, and let's say 64, right? So we created a string with which can, we created an array of string which can contain at most 64 strings. And now what we are going to do is we are going to convert the inputs into tokens, space based tokens, and then we're going to like execute that command. So first foremost, let's convert that to token. And to convert our input to token, I'm going to use a utility provided by C, which is stir talk. And this basically does what it basically, what the name of the function is, it converts strings to token, and in a very interesting way. So let's go at this. So input, right? I provided my input, and then the sequence basically from which I want to create tokens, right? So our sequence is space because we want uh tokens to be basically separated by this sequence, right? So we to space, and now what we're going to do is we're going to run a while loop. So, and I'll explain in a bit, but we need an I as well here. So let's see. So what I'm going to do is while token is not equal to null. So that means we have a token still in the string, and we don't want our max arguments to overflow, right? So I max args, I until it is smaller than max arguments, we are going to like run this loop. Now here is the interesting part. So we're going to say args I equal to token, and then we're going to say token equal to stir talk again, but instead of string we're going to say null, and our sequence still to be space. Now This is where things get interesting. Stir to talk. So, for example, stir to talk, we provide an input, we provide a sequence. So, it is, for example, in case of ls, it will take ls and put that inside token. The token is not equal to null, it goes inside it. But then, stir to talks actually internally keep a pointer to the position where it basically, um, get the token from, or where the first token or whatever I token it is on, whatever the last token it basically extracted off from the string, right? So the position is here in the hyphen LA, and then we say stir equal to null. That means just use your internal um, string which was input and still do the same thing. So we put inside token and we do the same loop, and it then in the next loop um, it basically goes. So I have to do I plus plus here. So we increment the I, and then next token gets saved, and it keeps happening until there is no more token to return, and then it becomes null, and yeah, or there are max arguments and whatever. And that's like very interesting. The other thing that I want to do, I want to try this. So instead of doing this, I'm just gonna do I plus plus here. Um, so what will happen is it will save it inside I, and then it will increment the value of I. I'm a lazy programmer. So, but yeah, so args what I'm gonna do is I'm actually going to null terminate this, just the way we did the string. But the reason I'm doing it is because we had a fixed memory here, so we'll always have 64 uh places in our 64 string you know blocks assigned to this array, and I don't want to go and um search through all these, right? So what I do is, what I did is basically, ls hyphen la. So ls it will be in the zeroth, hyphen la will be in the first, and then the second will be null. So we know that we don't have to search for arguments after that, right? So we'll not. We did that. Now let's actually execute these commands, right? And for that, again, we're going to use very interesting thing, and we're going to use fork. So let's do that. For fork, return basically a PID, and for that we need a type. So PID and PID is our variable equal to fork. Now fork is a very interesting thing, not auto importing. So let's see. I think it is inside uni. Let's say include uni std dot h. Yeah. Okay, so it's inside uni std dot h. And I'm not going to use this actually. Use this uni std.h. Great, right? So fork is like very interesting, right? So, and it is very powerful as well. So what fork basically do is it creates a copy of the same program, which of our program, and it will create like a different, and it will run it in the different process. And not only it will copy our program, it will also copy like the memory or the variables and everything. So basically what will happen is like you have this program, right? And when you do fork, it will create a clone of that program, and after the fork the execution will be different. And I mean, this is mind blowing in a way, but I mean, I really like, and I think it's really powerful as well. And the reason we want to do that is because when we will run commands like ls and all that, the operating system will, if I just go ahead and run ls inside this program, operating system is gonna replace this program with ls, and that basically means that our program basically get closed, right? And we don't want to do that. That's why we do fork. Fork will create another process, or you can say child process, and in that child process will execute the command, and that child process will get basically overwritten by the whatever command we are trying to run, and our parent program, which is like our which created the fork, still will keep running, and that's what we want, right? We don't want like oh, let's ls and then exit out of the shell, right? We don't do that. So what fork do is basically returns a PID. And the reason we need a PID is because the program itself doesn't know if it's a parent program, it's a child. And that's the beauty of fork, right? Fork the program and copies like all the memories and variables and all that. Now, both program doesn't know if they are the child one or if they are the parent one. For that, we need PID. So if PID is equal to 0, right, that means you are the children, right? Which the new process where we have to execute the command which user um, inputted. And if you're not 0, but PID is bigger than 0, then you are the parent program. Okay. And else you are, you know, there is an error, right? So something happened, So we're just gonna say P error for failed. The reason I'm using P error because it also adds additional error information about what happened. So if PID equal to 0, we are going to execute the command. For that, we are going to use execvp. Execvp is going to take arg0, which is the initial command, which is like ls, and then all the arguments. Okay, so all the argument basically like this, and that's pretty much it. Like this is what you need to do. And if it works out great, then none of this code will get executed. Even the code that I will write here will not get executed because ls will take over our program and our program basically vanishes, at least like the child process. So what I'm going to do is I'm going to put an error here because if code reaches here, that means our exec command failed. So exec vp failed, right? And I'm gonna do an exit and I'm gonna say exit failure, that oh, our program had some issue basically, right? So I'm gonna exit, right? So that's great. So if we are child, we do the fork, and if now we are in the child process, we will execute the command and it will take over our program child process. If there is an error, then it reaches this section, and then it will. But if you are a parent, then you basically wait command that process to get completed, and then show user that it is completed, or just continue the loop again, the while. What you're gonna do is what I'm gonna do is in status. So status will be like what happened with that process. I'm gonna say wait for PID. I'm gonna put the PID in here. We got from the top, and wait for the process. I'm gonna pass the reference to status so it can get modified, and 0 is like it needs to be normal. You can read more about wait PID, but in gist, in briefly, it is just we're waiting for the child process to basically get closed, and then we going to print that exist whatever the exist status was. Let's do that, and $d/n, and let's say status, right? So basically what we're doing, if there is a child process, we execute the command, it takes over. If it doesn't take over, that means it failed. Print it. If it is a parent command, we created a status integer to basically read the status back. We wait for the PID. It also modifies our status, and then we print the status. And that's pretty much it. And also, I'm just gonna now let's see if this works, or we made any mistake. We compile, it compiles, so no syntax errors at least. Now let's start the shell, and let's do ls, and you can see it listed the files here, like ns and ls-la, right? So kind of like works as a shell. And you can run like other commands as well, like you can run ls, I guess. Yeah, so you can basically have like all these functionalities as well. So all the commands basically run, and you can see exit status 0, 0 mostly means in a process, mostly means success, and kind of works, right? But here's the catch. like most of like ls command, right, or echo, these are, for example, echo, you know these are kind of like operating system built binaries and all that, but there are things which we have to implement, which is, for example, change directory. Change directory is not a operating system, a kind of a shell command. It is basically an inbuilt shell command. So if I try to do change directory and then do ls, it will not actually change the directory, you can see. So we have to implement. So how can we do that? So we're going to use the same logic as we did in exit, but the problem with exit is that it doesn't take an argument and all that. So we have to put the code after we got like the arguments, right? So what I'm going to do is if string compare input, not input, because input is like the whole thing, right? So we don't want to compare because we don't know what the argument is going to be, right? So we're going to compare arg0, because arg0 is always the command that was put it, and then we're going to compare this with cd to equal to 0, and then we are going to say if args1 is equal to null, and it can be null if we only type cd, then it's like we are missing the arguments. So we're going to say p error cd missing our arguments, right? And if it is there, then we are going to use a function which will help us to change the directory of the process that is running, which is change dir, right? And then we're going to provide which directory you want to go. So args1, right? Then not equal to 0, not equal to 0. The reason we do not equal to 0 is because is like if it is not successful, if it's equal to 0, that it means that it is successful. But if it is not equal to 0, that means it was unsuccessful. In that case, we're gonna do a p error, right? So we're gonna say cd failed, and then we want to continue the loop. So we don't want this logic to get be there, because we already handled it here, we already changed the directory, so we just continue and we start from the start basically, right? So we do that. Now if I do cd right now, it doesn't work. I exit, I compile the TinyShell. Now we have the TinyShell, we do ls, I do change directory dot, and you can see the projects. Then I can again do TinyShell, and if I do ls, you can see ls finale. So yeah, and this is pretty much it, right? So this is a very simple shell built in C. I'm going to obviously keep working and improving and adding more feature into this. I have some features aligned like history, and also like supporting up and down keys, which you can normally do in a shell, and also like background jobs. And I also want to integrate LLM right into this um, shell. So yeah, I mean, it will be interesting. And if you want to be part of that, I'm gonna put a GitHub link to this code, and you can actually go ahead and have a look at that. And with that being said, that's pretty much it for today. And I hope I'll see you guys in the next video.